If I told you that I would give you $1 million if you could randomly pick a red ball from one of these two boxes, which box would you pick from? The one on the left. Why? Because though both boxes have 5 balls in them, the box on the left has more red balls. Or you have more of a chance to pick a red ball from the left box. For the next couple of lectures, we will be focusing on how to quantify these chances or likelihoods. This will be done through a study of mathematics called probability. If I roll a die, it could possibly land on 1, 2, 3, 4, 5, or 6. These are the only and all of the possible outcomes that can occur if I roll a die. If I create a list of all of the possible outcomes, we call it the sample space. Notice how numbers such as 7, 8, and 0 are not in the sample space, since the die can never roll to such a number. So, to reiterate, the sample space is a list of all the possible outcomes of some procedure, such as rolling a die. Now, if I take a small collection from the sample space and create a mini list from it, we call this an event. For example, if my procedure is to roll a die and get an even number, then the collection I'm looking for are these numbers. This collection is called an event. If my procedure is to roll a die and get a number less than 3, then the collection or event I'm looking for are these numbers. If my procedure is to roll a die and get a number that is 3 or more, then the collection or event I'm looking for are these numbers. To reiterate, the sample space is the list of all possible outcomes, and an event is a smaller list with some of these outcomes. If I were to have a list with just one item in it, we would call this a simple event. So if my procedure is to roll a die and get a 6, the single outcome I'm looking for is this. Since there is only one item in our list, we would call it a simple event. If my procedure is to roll a die and get a number less than or equal to 1, the single outcome I'm looking for is this. Again, since there's only one number in our list, we would call it a simple event. So to reiterate, a list of all the possible outcomes is called the sample space. A list of some of the possible outcomes is called an event. A list of just one outcome is called a simple event. Can you identify the sample space, an example of an event, and a simple event? Let's try to find the chances or the probabilities of some of these events. A probability can be found by taking the number of ways an event can occur and dividing by the total number of items in the sample space. Let's find the probability that we will get 2 heads in our 3 coin flips. Let's find all the ways 2 heads can occur in our sample space and put them in a list called an event. Three out of 8 is 0.375. To turn this into a percentage, we just multiply by 100 and add a percentage sign. So the probability of flipping a coin 3 times and getting 2 heads is 37.5%. Find the probability that we will get 2 or more tails in our 3 coin flips. Four out of 8 is 0.5. To turn this into a percentage, just multiply by 100 and add a percentage sign. So the probability of flipping a coin 3 times and getting 2 or more tails is 50%. Let's try another example. Given a standard deck of cards, find the probability that you will draw a heart. There are 13 hearts in the deck, and there is a total of 52 cards. 13 over 52 is 0.25. In percent form, that would be 25%. So if I were to randomly pick a card from a standard deck, the chance that I will draw a heart is 25%. Given a standard deck of cards, find the probability that you will draw an 8 of diamonds. Since there's only one 8 of diamonds in the deck, and there are 52 cards in total, 1 over 52 would be my ratio. So if I were to randomly pick a card from the standard deck, the chance that I will draw an 8 of diamonds is 2%. Mathematicians use special notation to simplify these phrases. Instead of writing the word probability, they just use the letter P. Instead of writing the word of, they just use parentheses. And instead of writing out a description of the event, they just use some symbol, often a letter, but it could be a shape, a number, anything really. One thing to note is that probability is always a number between 0 and 1. In percentage form, that would be between 0% and 100%. 0 being the probability that something cannot occur, and 1 being the probability that something will occur without a doubt. There are 3 types of probabilities. The first one is called classical probability. This is where all the items in the sample space have an equal chance of occurring. All the examples we've looked at thus far were approached classically, but sometimes it doesn't make sense to use classical probability. Imagine if you are asked what the probability of getting into a car accident is. If you approach it classically, there are 2 possible outcomes, and only one simple event that applies. Thus, it would be 50%. This means there is a 50% chance of you getting into a car accident every time you drive a car. But we know that's not true. People don't have car accidents every other time they drive a car. We've produced an incorrect answer because we gave an equal chance to car accidents occurring and no car accidents occurring. Since the chances are not equal, we must use a different probability method called relative frequency. This is when the outcomes in the sample space may not have equal chance of occurring, so what we do instead is conduct an experiment or set up an observation that will help approximate a probability. The more times we repeat a procedure, the more accurate our prediction becomes. This is what we call the law of large numbers. So, if we want to know what the probability of getting into a car accident is, we can take all the cars in use in a year and the number of them that have crashed. Each car would be considered a repeated procedure, and each crash would be considered an item in my event list. If I take their ratio, I can find an approximation of the probability of getting into a car accident. Now this number seems way more reasonable. In this example, it's easy to get the denominator incorrect. So you have to add together the respondents that do use and don't use the social networking sites. Lastly, we have a subjective probability, which is just an opinionated response dependent on our knowledge of relevant circumstances. Imagine asking someone what the probability of Trump being re-elected is, and they tell you 70%. There are no figures calculated here, this is just an opinion based on their experiences.